Systecon are experts in producing world-leading logistics software. The tool suite includes OPUS10, a comprehensive and flexible model that enables the identification of maximum availability for minimal cost by recommending an optimum spares assortment, repair policy and support structure. It is now one of the world's most powerful logistics support optimization programs. This demonstration describes OPUS10's LoRa capabilities and how a LoRa problem is defined in OPUS10. In addition to the normal capabilities as described in the other OPUS10 demonstrations, OPUS10 has the ability to determine an optimum repair policy for an item or range of items. This location of repair analysis, LoRa for short, can be executed in isolation to a normal sparing problem or alongside it. The result of a LoRa modelling exercise will be a repair or discard recommendation for an item or items and the associated resources for the repair option together with the optimum spares mix. Note also that unlike most LoRa tools, OPUS10 does not use levels. Each station is treated independently of the others at the same level. This means that in some legs of an organisation, items may be recommended for repair close to the operating base, whilst in other legs, repairs may be more centralised. Let's look at a simple scenario, at how it would be represented and some of the results that would be generated. Initially, the OPUS10 model is defined in the usual way, as described in the OPUS10 input demonstration. So the equipment breakdown structure and logistic support organisation are unchanged. Further, the repair and storage data for items not included in the LoRa aspects remain unchanged. For the item or items included in the LoRa exercise, the resource and team forms are added as necessary. In this example, we will consider the option of discarding LRU7 and LRU11 at the central store, or repairing them at the local or central repair facilities. If the items are repaired, LRU7 requires a piece of test equipment and a trained technician. LRU11 requires a specialist tool and another trained technician. These are both declared in the resource table. Each resource is allocated an investment price and annual cost. Both can be overridden by location if required. Next, we have to allocate teams. Teams are effectively capabilities. They are used to connect items to resources and are defined in the team table. In this example, each item is allocated a different team, but normally items that require the same resources would be assigned to the same team. In the team item table, the items included in the LoRa exercise are assigned to the appropriate teams. Note that even if an item type has been declared in the item table, as they are assigned to teams, the colouring on the equipment breakdown structure is changed to white. This indicates that the item type has not been defined and will be determined as a result of the LoRa run. This is an example of data defined for the LoRa element of the problem overriding data defined elsewhere. The team resource table is used to assign resources to the appropriate teams and define their utilisation. Now we can define possible recovery options. In the team autolocator table, stations to be considered for the item repairs or discards can be defined. OPUS10 will consider all possible combinations. If only specific combinations are to be tried, then the team allocations table must be used. If both tables are populated, OPUS10 will consider options that are a union of the two. Now that the possible recovery options have been declared, the data associated with each option needs to be detailed. Repair data is defined in the team item repair table and needs to be specified for each repair location. If data is also included in the item repair table, the entries in the team item repair take precedence. For discard options, the data is defined in the Team Item Reorder table. Finally, the LoRa XT option needs to be selected in the Control Parameters table. Once run, OPUS 10 generates the normal cost-effectiveness curve. However, because the LoRa capability was employed, each solution could have a different repair policy for each of the LoRa items. In this example, point 9 selects a repair option for LRU7 and LRU11. This solution includes the optimum resource deployment, spares mix and repair location. If we move to point 10, a discard option for LRU7 has been selected, again with the optimum reorder policy and resource allocation. Note also that for both options, all other items included in the model are optimized normally. In this demonstration, we have seen a simple scenario using the OPUS 10 location of repair capabilities. This is a very powerful feature and allows systems to be optimized in terms of support options and resources and spares requirements, therefore allowing decisions to be made about the support organization. It's important to note that this is merely an overview of the model and many features have not been covered. For more information about our tools, please select another demonstration. Or for more detailed information about our products, please contact us or visit our website at www.systecon.co.uk.